Hi all, this is Dhanalaxmi, working as assistant professor under the Department of Cybersecurity, Data Science and AADS. Today's topic I would like to explain on this topic called as Introduction to Data Science. So here in Introduction to Data Science, the various content that I would like to explain is what is data science, definition of data science life cycle, what is data science used for, data science job roles, applications of data science, three pillars of data science, what is data, definition of data, types of data, definition of distribution, notation used for distribution, and what are the metrics that are used to characterize the data. So these all are the topics that I would like to explain in today's session. Let us go to the first topic. So here the first topic we are going to discuss what is the data science. So when we go to the data science, here we can analyze that data and science are two words or the two keywords that makes a lot of sense in the definition of data science. So let us move to the topic what is the meaning of a data. So when you go to the data, a data is nothing but it is a raw information that is used to collect the data, that is used to process, that is used to collect the data, or it is used to store the data, and it is used to process the data. And we know that when we go for the data may be anything. So when we go for the data, it may be the images, it may be the numeric data, it may be the like you can say it may be the music or whatever it may be. Now, and one more very important thing that we would like to say is when you go for the data, we can collect the data from various different devices. That is nothing but when you go for the data, we can collect from various different sources. That is, it may be the media, or it may be the transactions, or it may be the centers. Next, let us move. When you are going for the data, there are two types of data, that is structured formats and it may be the unstructured format. So this is about the data. Now let us move to the next keyword, that is science. When you go for the science, as we know that it is a systematic study and investigation of phenomena using scientific methods and principle, and it involves the forming of the hypothesis, conducting the experiments, analyzing the data, and drawing the conclusion. So in this one, we came to know what is a data science. Let us to move to the next topic, that is definition of a data science. In the previous slides, we learned the different what is the meaning of a data and what is the meaning of a science. Now let us combine these two keywords and let us see what is the definition of a data science. Let us see what is the meaning of data science, definition of a data science. So a definition of a data science is nothing but it is an interdisciplinary field that uses the scientific methods, processes, algorithms, and systems to extract the knowledge and insights from the structured and unstructured data. So this is the definition of data science. Let us move to the next topic, that is this is a life cycle of a data science. That is very important, means when you collect the data, what are the different steps that involve to get the data. Now let us move to the life cycle of the data. What is the first step that is there? That is a data collection. So when we move to the data collection is nothing but collecting the data from the various sources. Now, this is the first step in the collection of the data. Now, let us move to the next topic called as data preparation. So, data preparation is the second step in the data science life cycle. So, what is data preparation? Data preparation, nothing but cleaning the data for the further analysis. As you can see in the picture, when you go for the data collection, we are having the different how the data is there. When you go for the data preparation, you can see when you clean the data, how the data will be. Now let us move to the next life cycle, that is exploration and visualization. So exploration and visualization is nothing but here in this understanding the hidden patterns to the data analysis. Now you can see in this stage, that is we are separating the data, different types of data. That is the meaning of exploration and visualization. Next, let us move to the next step of life cycle, that is experimentation and prediction. So experimentation and prediction is nothing but we are creating a machine learning model to evaluate the data. As we have seen in the figure, you can see what is happening here. We are developing a model to collect the data. We are developing the model to analyze the data. Now let us see the last step in the data's life cycle is data storytelling and the communication. It is nothing but where we can visualize the data. Means as we know that when we see the data in the handwritten form, and it is very typical to understand. If you visualize the data in the form of visualization or in the form of reports, we can understand the data very well. So this is the data science life cycle. Now let us move to the next topic. What is the data science used for? Here we can see it is used for 4 different types of analytics. What are the different types of analytics that we are using for the data science? That is, the first one is descriptive analytics. So when we move to the descriptive analytics, the name itself, it's to say that we are dealing the data, what happened in the past. Based upon the past data, we are going to analyze the coming data, that is forthcoming data or the future data. Now let us move to the next analytic, that is diagnostic analysis. Diagnostic analysis is nothing but it is going to deal why it did it happen in the past. What is the major reason why it had happened first, so that we can take the necessary steps in the future. The next one, we are going to see the predictive analytics. So predictive analytics is nothing, it deals with what will happen in the future. Based upon the existing, we are analyzing the future data, what is going to happen. Next, the last analytics is prescriptive analytics. Means it nothing but how can we make it happen. So this is all the different types of analytics in the data science. Now let us move to the next. These are the, in this one we can understand what are the various job roles. When you go for the data science, when we study the data science, what are the job roles one can get. That is, a job role maybe he or she can become a data scientist, or data analyst, or data engineer, data architect, ML engineer, BI developer, and database administrator. So these all are the various job roles that when a person opted this data science. Let us go. As we have seen in the picture, we have seen what are the different jobs. Now let us go a little bit brief what a data scientist will do. So a data scientist is nothing but he is analyze a large data sets, developing the machine models, interpreting the results, and providing the insights to inform the business decisions. So these all are the roles that is made by, that is going to be done with the data scientist. Now let us move to the next one, that is data analyst. So data analyst is nothing but he is playing the role of collecting the data, cleaning, analyzing the data to identify the trends, patterns, and insights. Often it involves creating the reports, dashboards to communicate and finding the stakeholders. So these all are the different works that is done by the data analyst. Now let us move to the next job role, that is data engineer. So what a data engineer will do, he'll design and build the data pipelines to collect, transfer, and store large volumes of data, ensuring the data quality, reliability, and scalability. Now next let us move to the data architect. So what the data architect will be doing, designing the overall structure of the data systems, including the databases, data lakes, and data warehouses, and also defining the data models, schemas, and data governance policies. So these all are the tasks that is performed by the data architect. Now let us move to the next designation, that is machine learning engineer. So what this machine learning engineer role, that is he will be building and deploying the machine learning models at scale, optimizing the model performance, and integrating them into production systems. So these all are the specific tasks that is going to be done with the ML engineer. Now let us move to the next one, that is business intelligence developer. So what he is going to do, gathering the requirements from the business stakeholders, designing and developing BI reports and dashboards, and not only that one but also providing the data driven insights to support strategic decision making. Now let us move to the last role, that is database administrator. What he is going to do, he is maintaining the responsibility for managing a company's database, including its security, performance, and availability. So these all are the specific roles, or these all are the job roles which is performed by a data science student. Let us move to the next topic, that is applications of data science. It means where we are using the data science. Let us move the most important application in the healthcare. So in healthcare, it is used to diagnosis the disease, for the drug discovery, and so on. Let us move to the next application, that is in finance. When we go for the finance, the major role is nothing but it is used in risk assessment, and not only risk assessment but also the financial forecasting. The next application is manufacturing. So manufacturing is nothing but in the manufacturing, the data science used for predicting the maintenance, quality control, supply chain management. Next, the application is transportation. So transportation is nothing but the main role is route optimization, demand forecasting, and fleet management. These all are the various roles, or these are all the various important very important roles that is played by the data science in the field of transportation. Now let us move to the next one, that is business analytics. What is business analytics? What is the main role? With the help of this business analytics, he can do customer analytics, market segmentation, and nothing but churn predictor. And this is the various uses of business analytics under the application of data science. The next application is social media. So in the social media, the important role of data science is user behavior analysis, sentimental analysis, and also the content personalization. So these all will be coming under the uses of social media, which is one of the application of the data science. Let us move to the next application, that is e-commerce. So in the e-commerce, what are the uses? It is used for recommendation system, supply chain optimization, and price optimization. These all are the uses in e-commerce, which is one of the application of the data science. Let us move to the last application of the data science, is entertainment. So in the entertainment, how the data science is used? It is used for content recommendation, box force prediction, and gaming. Now these all are the different applications or most common application that is used in the data science. Let us move to the next content, that is the very important is three pillars of the data science. What are the three pillars of the data science? That is linear algebra, statistics, and optimization. So these three plays a major role in the field of data science. Let us go in deep. What is a linear algebra? So linear algebra is nothing. It is defined as, it is referred as, in data science, it refers as, it uses the mathematical concepts involved in the vectors, matrices, and linear relationship to manipulate and analyze the data. And also, it also provides the useful tools for most algorithms and processes in data science, such as machine learning, statistics, and big data analytics. So these are all the specific roles, these are the specific uses of linear algebra, how it helps in data science. Let us move to the next pillar, that is probability. So as we know, the probability is not, it is an estimation of how likely a certain event or outcome will occur. And also, as we know, that probability which is expressed in the way of zeros and ones, or even in the zeros and ones, or else we can say it's a true or false, which reflects the likelihood of an event that will take the outcome that will take place. And we have seen where 0 indicates not happen, 1 indicates it happened. So these are coming to the probability. Let us go to the last pillar of the statistics, is that the last pillar of the data science is statistics and optimization. Let us, what is statistics? It helps data scientists to analyze the data, extract the insights, and interpret the results. And some of the statistical techniques that used is hypothesis testing, regression analysis, and clustering. Let us move to the pillar is optimization. So what is optimization? It is a process of finding the most effective solution from a set of options to maximize or minimize a specific object. So these all are the three pillars of the data science. Now let us move to the next topic. What is data? By we can see a data is nothing but which is represented in the form of information, graphs, measurements, observations, facts, numbers, and quantities. So these are all nothing but these will be coming under the data. Let us move to the definition of the data. So a data is defined as, data is a information which is collected through the different sources and which can be qualitative or quantitative. In nature, mostly the data collected is used to analyze and draw the insights on a particular topic. So this is a definition of data. Now let us see, by this one we are going to learn what are the types of data. When you go for the types of data, there are two types of data, that is qualitative data and quantitative data. Let us go to the qualitative data. The qualitative data, which is categorized into nominal data, ordinal data. Now let us move to the quantitative data, that is discrete data and continuous data. Let us understand this all with the help of some examples. So let us understand what is CAD. Qualitative data, other than qualitative data, is also called as categorical data. So categorical data is nothing. It is a type of data that cannot be measured or counted in the form of numbers. This type of data are sorted by category, not by numbers. These data consist of audio, images, symbols, or text. It also tells about the perception of people. It helps in market researchers to understand the customer taste and the design and their ideas and strategies accordingly. Now let us go some of the examples. We can see some examples of categorical data. That is, what language do you speak? That is also one of the example. Favorite holiday destination, opinion on something, colors. Means these all will be coming under the qualitative or categorical data. The next one we are see when we go for the diagram in the qualitative data, which is further categorized as nominal data and ordinal data. Let us go with the nominal data. The name nominal itself, it is going to call as nominal. So nominal is a word which come from the Latin word called as nomen, which means names. It is used to label variables without any order or quantitative value. The color of hair can be also considered as nominal data, as one of the color cannot be compared with the another color. Let us move what are the various examples that we go with the nominal data. That is color of hair, marital status, nationality, gender, eye color. These all will be some of the examples when we go with the nominal data. Let us go to the ordinal data. So ordinal data is nothing. It is a qualitative data for which their values have some kind of relative position. These kinds of data can be considered as in between the qualitative and data and quantitative data. Let us see some examples. What is an example? Like examples, it letter grades in the exam, ranking of people, economic status, or education level. So these are the some of the examples coming to the ordinal data. Now let us move to the one more, that is quantitative data. So quantitative data is not, it is a type of data that can be expressed in numerical value and making it countable, and it includes some statistical data analysis, and these kinds of data are also called as numerical data. So when you go for the numerical data, the data can be used for statistical manipulation. We can see some of the examples of quantitative data. That is, height or weight of a person can be considered as quantitative data. It's a room temperature, time, or scores and marks. Now, when we go for the quantitative data, it is classified into discrete data and continuous data. Let us go with the discrete data. Discrete data is nothing but it is a distinct or separate. And in the discrete data, the data contains the values that fall under integers or whole numbers. And these discrete data cannot be broken. You can see the examples. What are the examples that we can see in the discrete data? It is total number of students present in the class, or cost of a cell phone, or number of employees in a company, or the total number of players who participate in the competition, or days in a week. Let us go to the continuous data. So continuous data represent the information that can be divided into smaller values, and the continuous variable can take any value. We can see here the key difference between discrete data and continuous data is discrete data contains the integers or whole numbers, but whereas continuous data contains the fractional numbers, and it contains the different types of data such as temperature, height, width, time, and etc. Let us see the examples. What are the examples? That be height of a person, which can be measured in 15.2 like that, speed of a vehicle, time taken, Wi-Fi's frequency, and market share. These all will be coming under the fractional part. Now let us go to the next topic, that is definition of distribution. So what is a distribution? A distribution in statistics is a function that shows the possible values for a variable and how often they occur. And distribution of an event consists not only the input value that can be observed, but it also made up of possible values. Let us see in this definition, we can see, let us see one example called a die. When a die which is having 6 sides, which is numbered from 1 to 6. And when you go for the probability, it takes the probability of 1 by 6, 2 by 6, 3 by 6, 4 by 6, and 5 by 6, and 6 by 6. Let us go to the notation of distribution. So when you go for the notation of distribution, here we are going to take capital Y as an actual outcome, small y as one of the possible outcome, and P of Y, capital Y equal to Y, it is going to demonstrate a probability distribution which is equals to P of Y. Let us go to the last one, that is metrics used in statistics. What are the metrics? We are going to use mean, variance, standard deviation. So what is the mean? It is nothing but the average, which is calculated by summing up all the values. And variance is nothing, it indicates how much values because it differs from the mean. That is another average of the squared differences from the mean. And the last one is standard deviation. It is a square root of the variance, providing a measure of spread of data set in the same units. Now let us see, these are the sum of the formula, that mean, which is taking the summation of I equals to 1 to n xi by n, and variance, that is I equal to n xi by nu whole square by n, and standard deviation, that is we are going to take summation under root summation of I equals to 1 xi by u minus u whole square by n. Thank you.